Hello everyone. So in this video, let us talk about the first three problems from the latest lead code biweekly contest 71. So let's start. The first problem is that you have to find out the minimum sum of the four-digit numbers after splitting digits. So the problem statement goes in simple terms. I'll tell you that you're given a number num and you have to divide that number into two different digits or two different numbers, sorry. Now, but there's also one more thing that you can shuffle out these digits as well. So you can shuffle out these digits and you have to divide this whole num into two different numbers. So you can split it, and the given num is always a four-digit number. Okay, so you can split it into like a one digit and a three-digit number, both two digits number, or a three-digit and a one-digit number. So there are three options, and you can split that number. Also, you can shuffle out the digits as you want, and then after dividing that number into two different digits or like two different numbers, you have to add both of the numbers out, and then you just have to tell out among all the various possibilities out there what is the minimum sum you can get, such that if you divide that number into two different numbers. That's the overall problem. Now, because the constraints are very small, as you can see, because it's only a four-digit number, you can just do this in a most brute force way. By brute force way is that you have to find out all the possible, let's say, permutations of the given number. Okay, what I mean by this is, let's say that you have the number, that the four-digit number, you are given as an input in the integer format. You first typecast it or convert it into the string number. Okay, and then find out all the possible permutations of this number. By permutation means that maybe one will come first and then two will come after, like all the digits will be permuted. And then for all the permutations, you have three options to either divide that number in such a way that there is only one number and three-digit number, two digits both number, and a three-digit and a one-digit number. So there are three possibilities for all the permutations, and because there are different various permutations for this number, you'll find out all of them and just print out the answer among all of the minimum of that. That's the overall idea for this problem, nothing more complicated. Just the code part you have to understand how you will write it down. So we'll directly move down to the code part to even make it more clear. What I've done here is that I've initialized a minimum value, that is among all the minimum value, I've initialized a very large number. And this is first I've taken the number nums and typecasted or like converted this num into a string number, because you can only do this over a string, like permutations. You cannot do this over integer value. Okay, then what you do, because you have to do the permutations, the number might be in a, so let's say that you start a permutation, then you will use this permutation function present in C++, that is the next permutation function. But for this function, it is always recommended that the permutation that you're starting with should be the very first permutation. Among all the permutations that will be created, the permutation from which you will be starting should be the first permutation. So what you'll do is that first sort it out the number so that you will come to the first permutation. So you have a number, you have typecast it to the string so that the number is now the same number typecasted to a string. You will first sort it the numbers. By sorting means that the digits will be like from the smallest to the largest. Then after sorting this whole out, what you'll do, because when you are doing this next permutation function, either you do in a do while loop. Do while loop means that you will first check the first condition and then go to the next condition. Or else if you are using a while loop, you have to first check or like call the function or like check out for this particular permutation that you have created the smallest number. You will check out what is the different splits of this number. I'll take you to the code part, like what is this calculate function, but you'll call this calculate function over this string. So now you have the string, so you'll typecast again to a number so that you typecast it to the string just to do the permutations. And when you get the string out, the final permutation, you'll typecast it to again integer and call this calculate function to get out what is the final different splits over this number and minimize that answer. And then you will do a while loop over all the permutations and call this calculate function over all the permutations and find an answer and minimize the answer. If you are doing a do while loop, then you can write down directly this menu condition in that, and that is all sorted out. But if you are doing a while loop, then remember that in a while loop, when this next permutation function is called, it will move down to the next permutation and skip the first permutation. And thus, like the first permutation answer will be skipped and the answer will not be minimized over all the permutations. If there is the first permutation left, and then it might happen that the first permutation will have the smallest answer and that is skipped. So I'm doing it here, but if you're doing a do while loop, you can directly write it down here. Now what is this calculate function doing? Now this calculate function takes the input of the number itself, and now I have three places to split out: the first position, second position, and third position. So that's what I'm doing. I'm splitting that number into two positions, doing a three while loop because just there are three numbers. So I have the num that we have, we first divided by 10 and mod it by 10 so that I will get the last digit and the first three digits. Then I mod it with 100 and divide it by 100. So I'll get the last two digits and the first digit number. Then mod it with 1000 and divide it by 1000. So I'll get the first digit and the last three digits. So that is how we will get the like different splits over this for loop, and I will minimize it such that this nums and nums2 are the different numbers that I will get after the splitting part, and I will just add them and minimize it over all the three splits and get the answer. So this calculate function will be taking a like a particular permutation and get me the minimum value for the particular permutations after splitting that permutation to different three numbers, like three parts, not three parts, two different numbers, but after splitting it out, whatever is the minimum among all the splittings, it will return me the answer, and I will call this function over all the permutations and get me the minimum among all the permutations, all the splitting, and return the answer. Because the constraints are small, that is why I'm doing in the most brute force way. So that's the overall code for this problem. The code for this problem will be in the description box for this problem, so don't worry. So let us move down to the next problem. The next problem is partition array according to the given pivot. Now this is a very simple problem. The problem statement goes like this. I'll tell you in simple terms. It states that you're given some numbers. Then there's also a pivot number that is given to, that is 10 in this example, if you can see. Now what they're actually trying to do here is that you have to somehow rearrange the numbers in this num array according to the three given conditions you have to satisfy. The first condition is that for every element less than the pivot number, it should be before the pivot number in that array that you will be forming after doing some rearrangements. Every number that is greater than the pivot should be on the right side, and every number that is equal to the pivot should be like they should be like maintained at one place, and you have to also keep track that the relative orders will not change. That's the whole problem. So as you can see that this is the array. Now all the 10s, because the pivot is 10, so all the 10s are here, all the numbers that are less than 10 are here, all the greater number are here, and because the relative order should not change. But relative order means that the smaller numbers than 10 are 9, 5 and 3. So they are in the same order, 9, 5 and 3. Like you should not be having that these are sorted, like they should be in a sorted manner. The order in which they are placed in the array should be remain same. So it is a very simple problem if you can observe it out. Why? Because what you can directly do here is that you can create three vectors or like three containers. The first thing is that just iterate over this string or like this whole array from left to right. Whenever you find out a number that is less than the pivot, you will insert it in some container that is called lesser. Okay, then you can insert all the numbers that are equal to the pivot in some container that is called equal, and you can like insert all the numbers that are greater than the pivot in some container called greater. So now you have three numbers, and because you've inserted in the same order, because you have done a same for loop, it will be inserted in the same order that you have encountered. So the order is remained same. Now you have three vectors or containers, whatever you can say, in which the numbers are there, and now in the end what you just have to do is that you iterate over the first, you have to put all the smaller numbers, then equal number, and on the greater number. That's the overall problem, nothing more complicated. So what I'm doing here is that I make three vectors, smaller, greater and equal, iterated over this nums using this auto keyword and for loop. Now what I've done is that whenever my ith number that I'm on is smaller than the pivot, I will push back into a smaller vector, then it is greater than pivot, so greater vector, and if it is equal, obviously else condition, it will be pushed in the equal vector. Then in the answer, this is the answer vector, I will be pushing all the numbers first that is in the smaller vector, then the equal vector, and then the greater vector, and just printing out the answer. Nothing more complicated. Now the third problem is they just have to apply some logic, nothing more complicated here as well. The problem statement is, I'll tell you, this is the minimum cost to set cooking time. Okay, the problem statement states that you are given a microwave that is having a number plate. Okay, number plate that you have to, like, let's say that you are using a microwave, so you will be pressing out some numbers now. So there are two places. So if you see the microwave is like this, then this is some hour plate, not, let's say it is a minute plate, and this is the second plate. So this is like 0, 0, like 0, 0 and 0, 0. Now what you can see is, let's say that you want to do the cooking for, let's say 35 minutes and let's say 27 seconds. So what you'll do is that you first typed 3. When you type 3, 3 will come here. Okay, then you type 5. So it will like shift on the left side. So it will become like 3, 5. I hope you get the point. Then you'll press one more time 2. So it will be like this, 3, 5 and 2. And then you again press 7. So it will be like this, 3, 5, 2, 7. and then it will be like set to 3527, that is 35 minutes and 27 seconds. That is how a typical microwave works, if you know how this is. But this is the overall idea, that you are like typing out, like pressing out the keys in this in this order only, that whatever is given to you, that if you want to do this for 35 minutes and 27 seconds, and then like the microwave will start working and out, and that is all problem. Now there's a little bit twist here. Now let's say that if you want to do what you can say, let's say that you want to do it for 9 minutes 37 seconds, so it is 9:37. Now 0 is there, like because 0 is everything, like it is all like initialized 0 only. You could have also done like this: you first press 0, then you press 9, then you press 3, and then you press 7. Or you could have also done that you just press 9 and then press 3 and then press 7, so it is also equal to 9:37 only, because 0 is always in the starting. I hope you get the point. This is also one of the ways. Now the problem statement goes like this, that there is a start at position. So you're just assume that there's a finger of yours that start at some given given number on the numpad that you have, like the microwave that is having a number pad. So you start at this start at, there's a move cost. By move cost is, let's say that you are on some digit on a numpad and you move to some another digit, so you have to print like 0 5. So you, let's say that you start from 0 and you're going to 5. So because you're moving, you have to like do a move cost. Now there's a push cost, because you are pushing some buttons, so you have to do a push cost. And this is the target seconds, that let's say that you want to do or like initialize your microwave such that you want to do a target seconds of 57, like 5700 seconds you have to do, or whatever number that you want to do this typical run. So you have to do that. Now you start at this, you have a specific target seconds. Now what is the minimum cost to be encountered by you to set the microwave to this target seconds? That is the overall problem. So I'll tell you with example, don't worry what is the problem statement is. The first problem will make it everything more clear. So what you can see here is that you have a start at 1, which means that your finger is initially at the first number on the numpad that you have on the microwave. Then move cost is 2, which means that if you move from one number on another number to the on the numpad, it will take you 2. You can assume it to be anything, like it's just a number out here. Push cost is that if you're pushing a button, that it is equivalent to 1 point, and the target second is 600 seconds, that you have to somehow set the microwave to 600 seconds. Now if you can directly see here that 600 seconds is equivalent to 10 minutes. Also one more thing in this problem is that in both of the cases, that this point and this point, okay, you can set 99 as the maximum number, that is the 99, which means like 99 minutes and 99 seconds, because these are like individual you can assume that these are individual points. So this is like minute and this is second, this is like dot here actually, so it's like 67 minutes 37 seconds. So you can, because the maximum number you can go is 9 here, and this is also 9, so this is also 9, this is also 9. So the maximum time you can set on the numpad is like 99 minutes and 99 seconds. Also keep that in mind. So what you can see is that you have to either set 10 minutes, so you can set like directly 10 means that 1 0 0 0, or you can, like instead of that, you can have also inserted 9 minutes and 60 seconds. So by 9 minutes 60 seconds, you can have done like 0 9 6 0, because 60 seconds is like equivalent to 1 minute only. So 9 and 60 minutes is actually 10 minutes only, but you have written in some other pattern way. Or else, because there is a 0 9, you can have like that, like omitted 0, you can have just pressed 9 6 0. That is also done. So that are the different ways you can do to just get a total value of 600 seconds, and among all of them you have to find out the minimum. So as you can see that you start at the first digit, and then because you start at the first digit, you just have to only push it once. So there's only one push, and then you go from 1 to 0 digit, so it will be like 2 as a move cost, and then you will be pressing like 0 0 0 3 times. So like 1 2 3 times you have to push 0, so that is the push cost of 3, and then the total cost of like typing 10 minutes in the microwave numpad is equal to 6. Now you will be doing for this also and this also, and as you can see that this is for the first 6, then 12 and 9. So the minimum among all of them is 6, so you will be following that part that is having the minimum like the total cost. So that's the whole problem, how you can do that. Now you can pause out this video, nothing too much complicated. What you can see here is that that you have two options at every point of time. By two option means that like two or three options. The first is, let's say that the total seconds you have is less than or equal to 99. Then you don't have any option. You cannot, like, because the minute will not actually take place. Okay, or actually what you can see is like if it is less than 99, what you can do is that you put 99 all of that number here, or you could have also done is that you have taken some minute also, and you have all taken some seconds also. You have two options. Okay, so what you can do here is, and also for minutes also it can happen that it is like it's above 10 or below 10. If it is above 10, you have to print out all the digits in the minute hand, or else if it is like 8 minutes and 30 seconds, so 8 minutes will be like 08. So you have to take care of that condition. So nothing more complicated here as well. You have to just take care of these three cases. Like what if that I just put all of them in the seconds, nothing goes in the minute part, if it is happen, like if it is possible. Or else if I want to place everything in minute and second half, as you can see that you just have 600 seconds, so you just directly divide them out into the minute and second half eventually. Or else what you could have done here is that you have subtracted one number from the minute hand. What I mean is that what I've done here in this example is that it is 10 minutes. So what they have done is that you have subtracted 1 minute from the minute hand and added 60 seconds on the second hand, and that is equivalent. I hope you get the point. That is in 10 and 60, and it is like 60 and like I've subtracted 1 minute here, so it has become 9 minutes and added 60 here. But you should also keep in mind that this second should not over exceed 99, because let's say that if you subtracted 1 minute from the minute part and added 60 on the seconds half and it over exceed 99, so you cannot actually do that. So you have to also keep track of that if condition, and you just have to check among all the possible segments you have. Now if you have the particular time you have, now you can directly just find out how much like cost you will be incurred. So what you will actually do here is that you have the total time and seconds in your hand. What you will be doing is iterate over these numbers, and let's say that I will be starting at the first digit. So from first digit, if you are on the first digit, then it is fine, or you have to do the like move cost and then the move cost and then the press cost. Then you are on some another digit, then from that digit you have to go to the other digit. So either you are on that digit or you have to again incur or move cost and then a press cost. So it is going like this. So it is just like, because there are 4 digits only, it's just like of one approach to find out how much total cost you will be incurring, and then just this answer. So that's the whole problem. So I'll tell you in the simple part. This is the code part. It seems large, but it's not too difficult. So as you can see that if the target second time is less than equal to 60 only, because it means that it is less than equal to 60, so everything will be in the second half only. So I will be like calling this solve function with my minutes equal to 0, because nothing is transferred to minutes. All of them are in the seconds half, and I will be transferring out these parameters because that are needed in the solve function. That is the first case. The second case is I would completely divide that number into like in the minutes and seconds half. So what I'm doing is that target seconds divided by 60 and mod 60. So I will be cutting out that point. Now what I'm doing here is that I will be calling out this solve function. So let's say that my left part means that the minute part is over exceeding 99. So then it actually doesn't make any sense. Which I mean by this is, let's say I have 1 million seconds, but 1 million seconds maybe not be even like divided into minutes and seconds. So if my left part, that is the minute part, is less than equal to 99, then only I will call the solve function with this left and right. The second case can be that I will subtract my left by 1 minute and add it my right by 60 seconds, and then I just check that my right should not be over exceed 99. If it is less than 99, I will again call this solve function with the new left and right, and I will, as you can see that I'm always minimizing my answer over the answer that I'm getting, and I'm printing out the answer. So that's the overall logic. Now how this solve function is called. The solve function is there. Now this solve function A and B represents the minute and the second half. So minute and second both are having numbers. So it is like the number where we have. So for a minute and second, I will be like bifurcating the minutes into like what other 2 digits minute have. So like it's 98, so 9 and 8, or whatever like the digits. So first and second, first one first 2, second one second 2. First means that the minute one, like the minute first number, minute second number, second first number, and second number. So now we have the digits out. So and we start at the start at number. Now what I'm doing here is that if the F1 means because I'm pressing the first key of the minute first. If I am on that number, Like if that number is actually not equal to 0, which means that that number exists. And what you can see is, because if that number exists, then we have to somehow go to that number. But if that number doesn't exist, it means that it is 0 only, then we don't have to actually go there. I hope you get the point, because let's say the number is 09, so I will directly go to 9. Now I am going to 0, so that number, if it is not equal to 0, then I'm going inside. And if I'm going inside, I will first check that whether that number is the number I'm on or not. If the number is not on I'm dot number, I'll incur the move cost, or else the move cost will be 0. And when I will like reach that number, I will make my push cost, because I'm doing a push cost, and then my now, which means that the hand position now is at F1. Again, I will be going to the next position, and I will checking that whether the next digit is again 0, or if it is again 0, I will not have to move anything, or else I have to move to the next digit. And I will first check that the next digit I am on is the same digit. Then I will, or not, I have to move the incur cost, like I have to incur the move cost, or else I don't have to do that. Just do the third digits and the fourth digit. So all of that digits I will be doing that and just printing out the answer. This is just an O of 1 approach, nothing much, and this is also O of 1 approach. So the total will be O of 1 only. That is the logic for all the 3 problems. Thank you for watching this video till the end. I will see you next one. And you also do, if you have any doubts, you can mention down. So I'll see you next one. Till, like, keep coding, and bye.